Now we're going to take a look at this idea of a reference angle. A reference angle is going to be a positive acute angle. So this means an angle between 0 and 90 degrees formed by the terminal side of some angle theta and the x-axis. So let's take a look at this first example here where we're given the angle theta is 210 degrees. So as you know, I like to visualize and see what this angle is looking like. So we have our 90 degrees here, we have our 180 degrees here, and then down here we have 270. Now let me come back here. X-axis, we can see here our x-axis is this straight line here, which in terms of angles it would be 180 degrees, or over here it would be 360 degrees. So x-axis we're going to define as 180 degrees or pi, or 360 degrees 2 pi. So think of our x-axis in terms of the degrees. Now obviously we could also think of it as 0 here, but we're going to use the complete revolution of 360. So back to our angle of 210. We're moving in the counterclockwise direction. We go to 90, we go to 180, and now 210 is bigger than 180, so we continue to go. We're less than a 270, so we're going to end somewhere around here. So this angle here represents our theta of 210 degrees. In this section, we're going to be defining reference angles. And as it says here, the reference angle is between the terminal side of our angle theta and the x-axis here. So this here is our reference angle, and I'm going to call that alpha. So we're going to give it another Greek name, alpha. So now let's see how we could figure out what alpha is. Numerically, we see that we went to 10, we went to the 180 and a little bit more. How do we say that little bit more? We can write that as the statement 210 degrees minus 180 degrees is equal to 30 degrees. So this says we went 180, 30 more, 180 and 30 gives us our 210. So our alpha, our reference angle here, is going to be 30 degrees, positive, and it's less than 90 degrees. Now, taking a look at the next example, we have here 7 pi over 4. So if we take a look here, our denominator is 4, so here's our pi, and here's our 2 pi, but with the denominator of 4, we can express pi as 4 pi over 4. And over here in 2 pi, this would be 8 pi over 4, just so we can see with the given angle where we're going to be. And we know this means divide pi by 4. Each of these is pi over 4, 45 degrees. So now let's see where this theta is taking us. Again, counterclockwise, we go 1, 2, 3, 4, 5, 6, 7. So this here represents our angle of theta. Again, looking for the reference angle, which I'm calling alpha. This is made by the terminal side of our theta and the x-axis. So this angle in here, whoops, I made an infinity sign instead of an alpha sign, is our alpha. And how would we get that? This is going to be, we can see we almost went a full 2 pi, or 8 pi over 4, but this is the piece that we're missing. So let's subtract out this 7 pi over 4, and this gives us our pi over 4. 8 minus 7 is 1 pi over 4, which is our alpha. continuing on here, we have a theta, now a negative angle, losing my markers here, which means that we are going in the clockwise direction. So going clockwise, this would be 90, and this would be 180, and this would be 270, going in the clockwise direction. So we start here, we go 90, we go 180, we don't quite go to the 270, so our terminal side is going to be over there, and showing this, here is our theta. To create our reference angle, when we look, it's between the terminal side of our theta and the x-axis. So in this case, our reference angle, our alpha, is this angle in here. How can we calculate what this is? Well, we take our 240, so we see we went 180, and then to figure out this little bit more, we take our 240, 240 degrees, minus the 180 degrees, which gives us 60 degrees. So our alpha here, alpha is 60 degrees. Now, just to point out here, I ignored my negative sign with this 240 because the negative sign just tells us the direction we're going in. So we don't need to confuse ourselves with a subtraction with all these negative numbers. What we're looking for is the difference in degrees. So even though this is negative 240, we're just going to use the degrees, the angle measures as positives. 240 minus the 180 for our reference angle of 60 degrees. So now this brings us to our last example here. Our theta is 3.6, and we don't normally see angles given in straight radian measure. Usually when we're talking radian measure, we're looking at something like this that has the pi in it. But this pi has been evaluated using 3.14, yada, 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 to get a numeric answer of 3.6, no pi symbol included. So, but we can take a look at this. We know that this is pi here, and for simplicity, I'm going to call pi 3.14. We know it's more than that, but let's just keep it simple for this graph. So, we have 3.6. Again, we're going to go counterclockwise. So here we go. We hit the 3.14, and we know we continue to go more. How much more? Well, it would be useful to know what our 3 pi over 2 is in radian, straight radian. I call it straight radian, and that would be 4.71. So 3 times pi on your calculator divided by 2 would give you about 4.71. So we know our 3.6, we're going to continue to go beyond pi, but we're not quite getting, well, 4.71 is quite a bit. We're not getting there. So we're going to be ending, I'm going to say, somewhere around there. And since I'm making my thetas in red, this would be our angle theta. For our reference angle, terminal side of our theta and the x-axis. So we're looking at an alpha, a reference angle in here. And to find that using math, this would be our 3.6 minus our pi, which is 3.14. How much more is 3.6 from the 3.14? We would do that subtraction and get 0.46. So our alpha here, our reference angle, is 0.46 in radians. So if you look here at these, you'll notice we have reference angles in the second quadrant, we have reference angles in the third quadrant, and we'll have a reference angle that we'll need to find when our theta is in the fourth quadrant. We didn't find any reference angles in the first quadrant because in the first quadrant, all our angles are acute, so they already are, so to speak, reference angles. No need to find any new information.